All right, STAT1800, numerical summaries. This is an important part of the first lesson. And what I want to teach you in this video is if we're given a set of data that's quantitative, how do we summarize the scores? And just to get the kind of the ball rolling, if you will, I play a lot of golf, and I probably play 25 or 30 times a year. And if you were interested in what kind of golfer I am, which I'm sure you're not, you wouldn't probably want me to tell you all 30, 40, 50 rounds of golf. What you would want me to do is to just summarize how well I play golf. Maybe I would give the mean, maybe I would give the median. And it turns out that in learning more about numerical summaries that there are appropriate times to report one measure over the other. So that's kind of where we're headed with this. So kind of to motivate the whole idea of why we need to make multiple statements, specifically why we need to make center and spread statements when analyzing a quantitative variable. Let's take a look at this question. So the assumption is there's an average score for the first exam for a stat class that I'm teaching is 80. And we'll assume that there are 3 students. What can you say for sure? So just hit pause, think about it, maybe 5, 10, 15 seconds. What can you say for absolute certainty? Well, the only thing that I can say for certain is that the sum of the scores must be 240. Because think about it, for me to be able to get an average of 80, then we find the average by adding up the scores and dividing by how many students, well, in this case students, or scores in general that we have. So the only way that I can get an average of 80 is if I take the number 240 divided by 3, which obviously is 80. But let's think about that. Possible scenarios. It's very possible that all the scores were 80. It's very possible that maybe one score was 79, 180, 181. Again, the sum turns out to be 240. The third example I gave you, 75, 80, 85, sum is 240. And you'll see that even I get kind of goofy down there in the bottom. You'd have to be pretty silly to get a negative million on an exam. But let's take a look at the fourth one, or the fifth one down, where 00240. No one said that the exam was a 100-point exam. Maybe it was a 250-point exam, and 2 people didn't show up, and 1 got a 240. But anyway, the focus I want, or what I want you to focus on right here, at least temporarily, okay, is that the sum of the 3 scores has to add up to 240. To get an average of 80. Well, you can see that if we summarize this, all the examples had a mean of 80, but they told drastically different stories. Why? Well, because of the variation. 80, 80, 80 varied none whatsoever. 79, 80, 81 varied a little bit. It varied more than 80, 80, 80. But it doesn't vary as much as the third example I gave you, 75, 80, 85. And if you want to get down to complete chaos and variation, look at the last set of 3 numbers. Negative a million to 240. That's it, just crazy variation. So the point I'm trying to make is when we describe numerically, when we provide numerical summaries for quantitative variables, we need to learn to make more than just what we call a center statement. We also need to be able to address the spread, which we call the variation. Well, enter in a couple of things on numerical summaries. When we make a statement about a quantitative variable, again, let's circle back to my golf scores. If I was going to appropriately tell you or describe to you my golf scores for an entire golf season, I would need to make a center statement, which kind of represents the typical score, probably the average, and then I would need to make a spread statement, which measures the variability. Because there's a big difference in the golfer who shoots maybe 75, 75, 75, and the golfer who shoots 70, 75, and 80. The 75, 75, 75 still has a mean of 75, but complete consistency. You know what they're going to do every time out. 70, 75, 80, again, still a mean of 75, but less consistency in their scores. So again, center statements, we call these measures of central tendency. Spread statements, we call these measures of variability. Now, the types of statements that we're going to learn, center statements, we're going to focus on what's called the mean, median, and mode. The mean is just the arithmetic average. Again, these are things that need to go in your notes. I doubt you're going to, well, I know you're not. I've taught this class too many times. You're not going to remember everything. So the mean is the arithmetic average. The median, if we arrange the scores from low to high, it's the score that's in the middle. And if we have an even number of scores, we just average the two scores in the middle. You've probably seen this in previous classes. And the mode is the score that occurs the most. Spread statements, we'll talk about the range, the standard deviation, the variance, and the quartiles. We'll actually cover quartiles more in a future video. So, golf scores. Let's say that I shot these scores, 80, 70, 70, 79, 81. The mean, or the arithmetic average, which we will give notation as X with a bar over it, is just the sum of the scores divided by 5, because we have 5 golf scores. So in this case, it would be 76. The median would be the middle number when arranged from low to high. So I arrange those from low to high, 70, 70, 79, 80, 81. And the median is the score smack dab in the center. Now, we don't spend a lot of time doing these, calculating these by hand, taking a large data set and arranging them from low to high, and counting in to see which one number is in the middle. We have technology, namely StatCrunch, which I'll introduce pretty soon, that takes care of these calculations for us. The mode is the one that occurs the most, where the only two scores that repeat are 70, so the mode would be 70. Now, in terms of measuring variation, the range is defined as the high score minus the low score. And the high score is clearly 81, the low score is 70, so the range would be 11. And then we get into something called a standard deviation. Now, what a standard deviation, we'll tell most of you will look at that formula that I have down there. S equal the square root of the sum of squares divided by, turns out, by the degrees of freedom, n minus 1. More about that later, all right? Don't flip out on me. We can handle this. And you know what? Even if we can't handle it, technology is going to calculate the standard deviation. So really, all we need to tattoo to the brain at this point is that standard deviation is a measure of variability. It's a measure of spread. So if you got that down, I'm okay. But let's take it just a little bit further. So I wrote this out because it was going to be hard to type out. So what I want to do is just walk through the calculation. Again, don't leave me here. It's going to be tempting to say, it's too hard. I don't want to fool with that. Let me show you historically how this was all developed. If we dive into the formula right here, if we look at the part that I'm circling right here, the x sub I minus x bar, all that is we put our numbers in the first column and we take each of these numbers and then subtract the mean. Well, we know the mean is 76. So this value 80 minus the mean is 4. This value 70 minus the mean is -6, -6, 3, and 5. And we can see that when we sum up, that Greek letter right there, sigma, just means add up this stuff, add up this column. When we add these up, what do we get? -2, -8 plus 8 equals 0. Well, that's what people that were in statistics years ago found, that we call this the sum of the deviations, that the sum of the deviations from the mean will always be equal to 0. So when searching for an average spread around the mean to express the variation, they failed. So what they noticed is these negatives and positives were kind of balancing out to always give a sum of 0. So what they did is they squared this value. So instead of 4, they had 16. Instead of -6, they had 36. All of these became positive. So that eliminates the possibility of the sum being 0, unless, of course, all the numbers are the same. So now, if I add up this column, that's just going to be the sum of the x sub I minus x bar squared. And if you add these up, you'll see that you get 122. So this formula, standard deviation, can be given as an S sub x or an S. So this value right here, we saw to be 122. N minus 1, N is the number of pieces of data that we have. In this case, it's 5. So 5 minus 1 is equal to 4. So if I take 122 divided by 4, and if I take the square root of that, I get 5.52. So 5.52 is the standard deviation. And if I don't take the square root of the 122 over 4, I get 30.5, which we define to be the variance. So if I'm given a standard deviation, I can always find the variance by squaring the standard deviation. If I'm given the variance, I can find the standard deviation by taking the square root of 30.5. And give it a try. Grab your calculator and put 30.5 in there and take the square root of it, and you'll see that you get very, very, very close to 5.52. All right, so we're going to look at the application of this more on problems in my stat lab. But for now, I just want to introduce you to different measures of center and spread, or in other words, different measures of central tendency and variability. All right, gang, that's all I got.